Okay, so come on. So today we're going to discuss about we just discussed the questions about the op-amp. Op-amp. Can you see the slide?
No.
Okay, now can see the document? Can I?
Yes.
Okay. So today we're going to discuss the op-amp questions. As I said, this is the STPM one, but very quite useful. So what I'm going to do first round is I show the circuit. You tell me, is it what type of circuit is that? Is it inverting, non-inverting, comparator? Okay. How do you know it's a comparator and there is no feedback? It's a comparator. How do you know it's inverting? It must have a feedback. The input must be at negative. How do you know it's non-inverting? It must be a feedback. Input must be at positive. Okay. Let's go through that first. Okay. Okay, I go to this circuit here. What do you think? Is it comparator inverting or non-inverting? Anybody? Is this comparator inverting or non-inverting?
Comparator.
This is a comparator. No feedback. Okay. So you see the output, the input was sine, but output all saturated, all flat. Comparator always flatten the input, either positive or negative. That's the only thing he knows. Okay. Show more circuit. Okay, number 7. What type of circuit is this? Yeah, anybody? There is a feedback. Inverting, yes, good. Input is at negative. So it's inverting. Inverting, what is the gain formula? Inverting gain formula is 1 negative RF over R in. That's your gain. In this case, U is your RF, your S is your RF, the R is your R in. R in. RF is the first resistor on your feedback. So RF. Okay, good. So then this goes on. So this 8 also inverting. Input is at negative, that is a feedback. 10 also inverting. Input at negative, that is a feedback. 12 is, as I said, is a mixer. It's a mixer, a type of inverting, but got more than one input. The gain formula is different. They should introduce us. Okay. Okay, number 14, there is a mistake. The mistake is, okay. Okay, number 14, tell me what type of, just look at the diagram, tell what type of circuit is that? Comparator, inverting, non-inverting. There is a feedback, input is well. This is non-inverting, and this is non-inverting. Okay, so non-inverting, but later when they give solution, it looks like the input here, it tend to become inverted. Okay, was inverted, the answer solution they give. That means if the solution correct, that means they did a mistake in the diagram. What mistake they did in the diagram? So it should be a
negative is
yeah, the positive have to change to negative, the negative must be positive. It's an inverting amplifier actually. If we refer back, if we think the solution is correct. So bear in mind, number 14, the sign is wrong. Should be negative and positive. Okay, good. So this is how it works. Okay, number 17, what type of circuit is that? 17. There is a feedback. Input is where? Input is at positive. So inverting or non-inverting?
Inverting. Wait.
Non-inverting, right?
Oh, non-inverting because negative.
Non-inverting. This is non-inverting because input is at positive. Okay. What is the gain formula for this? 1 plus RF over Rin. Which one is RF? Which one is Rin here? How much is RF? How much is Rin here? The 9 is RF. The 5 is Rin. Okay, remember, when do feedback, the first resistor exposed is RF. Second one is the Rin. Okay, that is the inverting amplifier. Okay, so let's we go up. So we go one by one. It's just selected questions. Okay, we start with number. Go to number three. Number three. So look at number 3. The diagram below shows a sinusoidal input peak voltage 3 volt connected to the terminal of inverting input. The supply voltage is positive 5, negative, positive 15, negative 15. Sketch the input and output voltage with time if the non-inverting input kept 0. So they are saying, this is what they are saying. This is the circuit they used. Okay. The input was at negative, inverting input. The input signal was like sinusoidal. It's a sinusoidal. The positive was earthed, 0. 0. If positive is earthed, then the output going to be exactly like negative, but 90 degrees inverted, 180 phase difference, right? So what happened? Okay. So what happened? Hold on. Okay, so if positive is earthed, that means so output equals to the gain times V plus minus V negative. So this V plus is 0. So the output is actually going to be like the negative, but the input of negative, but is opposite negative. So you give a sign, it's going to be negative sign, but because it's a comparator, it can't show the sign. If it's a negative, all negative will tend to become all negative flat. All positive tend to become flat. So the entire thing going to become flat. So that's what shown here. What is shown here? So the first sinusoidal is positive voltage. The input is positive. Output will be negative. So negatively saturated will become negative 50. The entire positive become negative 50. The entire negative become positive 50. Saturated or saturate because it's a comparator. No such thing it can give like an intermediate value. It will always saturate. So this is the graph. This is the input. First sinusoidal is the input. The square wave is the output. Negative 15, positive 15. Okay. Okay, so that's the question for the first one. How the graph going to looks like, how the input and output voltage with time if the non-inverting is 0 volt. Okay, now the second case, they say the non-inverting now is kept 2 volt. How the graph going to looks like? Means what? Here non-inverting here, the positive 2 now not anymore 0. There is a 2 volt. So means what? Here they put 2 volt. They put a 2 volt. So positive now 2 volt. So positive is not anymore 0. It's 2 volt. So you are applying a sinusoidal wave of input of 3 volt. Here is 3 volt. Negative is 3 volt. 0 to 3 volt. From 0 to go to 3 volt, then become negative 3 volt. Fluctuating. Okay. But as long as this voltage is less than 2 volt, the negative is less than 2 volt, the positive is the winner. So output will be positive. So how the graph going to look like? How the new appearance going to look like? Can you imagine? So the appearance going to be like this. Okay. Okay. See. The negative is 3 volt sinusoidal. Negative, this is negative. The positive was 2 volt. Okay. The op-amp going to saturate either positive 15 or negative 15, depend who's the winner. You see the first region here, the first region, the positive 2 is greater than the sine graph, right? The positive 2, the first region. So positive input is greater than the negative input. So output going to be positive. So the first region become positive 15. Because positive 2 greater than the sine voltage. Sine voltage only rising, But before it become 2 volt, I think the positive is the winner. So output will be positive 15. Positive 15. Okay, the next region, the sine become greater. Then the flat line. Okay, the second region. Here, the negative input become greater than the positive input, right? Because this hump is greater than the flat line. So during this duration, negative will determine the output. So negative means it's going to be inverted. So what? So 3 volt become negative 15. Throughout that, because the winner is negative 15. And the third region, who's the winner? Third region, again the positive is the winner. Negative already go down. So positive, so output will be non-inverting, it won't invert. So it's going to be positive 15. So this is how the comparator will change. This is how the comparator change. And positive 15, negative 15, positive 15, negative 15 change. Last time was negative 15, positive 15. Just inverse the graph because positive don't have anything. But now positive got 2 volt. So 2 volt. So positive going to be winner partially at the beginning. Beginning positive 2 is greater. So output will be positive. Okay. In exam, they will ask you to trace this. Okay. Any questions? Hope you understand how to trace.
So that means that the positive input is there's now actually a voltage instead of 0.
Yeah.
Okay.
Last time was 0 volt, now given 2 volt. Okay. Okay, so this is comparator. Remember, comparator graph towards the end all going to be flat, either positive or negative. That's it, comparator. Okay, comparator easy, just flat always, either positive or negative, saturated. Okay, next one. I just go selective one. Okay, I want the tracing one. Hold on, let me check. Oh, this is derivation. Okay, number 10. Okay, look at number 10. So the circuit below shows an inverting amplifier because there is a feedback. Input is at negative. The supply is positive 9, negative 9. The series alternating voltage is connected to the input voltage as shown. Or the input voltage is actually a sinusoidal input, positive, negative. Okay. Sketch graph to show the variation of the output voltage with time. And the peak value of the alternating input voltage is 1 volt. And the peak here is 1 volt. Here peak is 1 volt. How the output going to be looks like? And 1 volt. Peak is 1 volt. So the pattern. Because this is an inverting amplifier, definitely the input going to be reflected should have phase difference of 180. So if this is a sine graph, of course, the output going to be a negative sign. Negative sign. But negative sign with what? What is the peak value? How to know peak value? Check the gain. How much is the gain? How much is RF? How much is Rin? So what is the gain formula? Negative RF over Rin, because it's a inverting amplifier. So 4 mega ohm divided by 1 mega ohm. So -4. The gain is -4, right? The gain is -4. Gain is 4 over 1. -4 over 1. Negative RF over R in. So the gain is -4. So if the input is 1 volt means output will be how much? Output will be 4 volt, right? Output will be 4 volt. If input is 1, gain is -4, output will be 4. So output will be 4, the peak value will be -4. So the graph going to change, become negative sign graph. The crest and trough will be -4 and +4. This is how the appearance going to look like. Okay. So this is inverting amplifier output. When input is a sinusoidal with a peak voltage of 1 volt, output will be inverted. Gain is 4, so the graph going to enlarge by 4 times. So this is how the graph should look like. Saturated or not saturated? All of them not saturated. Perfectly within the saturation limit. Any questions? Okay, so that's the first one. Next, they said what? Sketch this input graph, sketch the output. If the peak is 3 volt, peak is 3 volt. If peak is 3 volt means after amplified, peak going to be how much? 3 times -4. It become -12. So peak going to be -12. Is it going to be saturated?
Yes.
Yes, because it's only 9 volt, -9. But it's going to go up to 3 times 4, 12. So how's the graph going to look like? It's going to be partially saturated. Okay, it's going to be partially saturated. You see? This is how the graph looks like. Okay, you draw the original graph first. The original graph is inverted. Sign means negative sign, but it's going to be -12, +12. You draw that first, then you just cut off at +9. Just cut off at +9. So the final appearance going to look like how? The final appearance going to look like. Hold on. So the final appearance is going to look like a sinusoidal cut, sinusoidal cut, sinusoidal cut. Okay, it was like a chopped off. So this value should be +9. This value will be -9. This part has been thrown out because partially saturated. But the earlier shape going to look like a sine graph. These all are going to be the shape of the sine. Going to be shape of the sine. Only the top never appeared because saturation happened. Because the supply voltage only +9, -9. But the gain here they got is 12. The total output was 12. Can't afford to give 12. Okay. So good idea. So both are inverting amplifier. The first one peak was 1 volt, gain 4, so not saturated. But the other one is gain was 4, partially saturated. Class, can you hear me?
Yes.
Okay, look at 14. Okay, 14, as I said, the mistake is up and down. Up is supposed to be negative. Up should be negative. Okay, this should be negative, remember. Okay, up is negative, down is positive. So it's an inverting amplifier. Take it as an inverting amplifier. The input graph was like this. This is the input signal. 0 become 2 volt. So because it's an inverting amplifier, what happened? this pattern going to be reflected, right? This pattern going to be reflected the other way around. The positive peak going to be the negative peak. How much is the gain? Gain how much? Negative RF over in, so 120 over 20. The gain is negative 6. That means this 2 going to become 2 times negative 6 become negative 12. So peak going to be negative 12 like this. It's going to be supposed to go to negative 12. But again, the power supply how much? Only positive 6, negative 6. So it's supposed to go up to negative 12, but what happened? Cut off at negative 6. Okay, you have to draw the up to negative 12 first, then use a rubber, rub the where you need cut it at negative 6. The above cut it, just rub it. You get the new pattern. Up also become only up to positive 6. This is how the output going to looks like. Okay, in exam they'll ask you to draw graphs. So when you draw, don't think the shape going to be like the input shape. The output will definitely going to be magnified, but sometimes can be partially saturated. Okay, be careful. Always refer back to the power. How much is the voltage they apply? Okay. Any questions? No questions. Okay. Yeah. So another one question is is okay. This is the graph I told you, I explained to you. This is the gain versus the frequency graph. This is the original line where the ideal op-amp changes is what do you call? It's gain. So if you do feedback, gain drop. So the dotted line, a new line will form. So what happened? The bandwidth increases, greater bandwidth. Greater bandwidth, less distortion, more stability. This graph is missing in your PowerPoint. Okay, so I told you to add, right? Gain versus frequency. Okay, so this you can go through this. Okay, this slide. Okay, now let's go to the pass here. Okay, this is the pass here. This is your pass here. The earlier one is STPM, but as I said, quite useful. Okay, so let's see one questions. Okay, give a try. First, state 3 characteristics of ideal operational amplifier. Okay, there are 5. What are they? They have you talk about impedance, you got two features already, right? The input impedance is infinite, output impedance is 0, the gain is infinite, the slew rate is infinite. Okay, slew rate is infinite, the time delay the slew rate is infinite. Another one is what? Talk about gain, impedance, bandwidth. Bandwidth is infinite. Okay, the bandwidth is an infinite bandwidth. So you need to remember at least 3 infinite bandwidth, infinite slew rate, infinite output impedance. Infinite input impedance. Okay, infinite slew rate, infinite gain, infinite bandwidth, infinite slew rate. Okay. Okay, so now let's go to here. Okay, look at this circuit. Remember, whenever you do op-amp question, first, without reading the question, check, is it comparator, inverting or non-inverting? This circuit is what? Comparator, inverting or non-inverting? Anybody? What type of circuit?
Inverting.
It's inverting, because there is a feedback. There is a feedback connecting back. So this is the inverting amplifier. Why the inverting or non-inverting? Sorry. The input is where? Input is at positive. This is a microphone. And this is a microphone. Microphone connected to positive. So input is at positive. So this is non-inverting. This is a non-inverting amplifier. Because microphone voltage going to change. So the input is positive voltage changing. So remember what gain formula to be used? Sorry, play this person. Okay, what is the gain formula? Comparator, what is the gain? Comparator gain is 10 to the power 5 lah, fixed. For for inverting, what is the gain formula? Negative RF over Rin. For a non-inverting, 1 plus RF over Rin. Yeah. So in this case, you have to use this gain formula lah, because it's a non-inverting. 1 plus RF over Rin. Okay, tell me from this circuit, what is your RF? What is your Rin? 120 is your RF. Your RF is 120. The first resistance when doing the feedback is RF. The second resistance X, it should be your Rin. X is your Rin. Okay, good. So those who discover when you look at the circuit, it's a non-inverting amplifier, immediately write the gain formula on the paper. Okay, don't wrongly choose other gain formula. You go for other gain, then wrong everything. So make sure the gain formula is correct. To find which gain formula to be used, you must identify, is it a comparator, inverting amplifier, or non-inverting amplifier. This is a non-inverting amplifier. Why? There is a feedback. The input is at positive. Okay. Okay. So first, name type of feedback used in this op-amp. So what type of feedback is this? This feedback is the feedback to where? To the negative. So this is a negative feedback. Okay, it's a negative feedback. The type of feedback is a negative feedback. What is negative feedback? What is negative feedback? A fraction or all the output is channeled back to the inverting input. That's called negative feedback. Okay, all or fraction of the output channel back into the negative input. It's called feedback, negative feedback actually. Okay, next. The output potential difference V out is 5.8. For a potential difference across the resistor is 69 millivolt. Calculate the gain of the amplifier. So what is that? You see, output is 5.8. The R resistance is 69 millivolt. If R 69 millivolt means the voltage used by the microphone is 69 millivolt. Means voltage input here is 69 millivolt. They're asking what is the gain. So gain is always, of course, we know gain is in this case is what? 1 plus RF or Rin. But they give, there is another one common gain formula, right? Actually, gain is what? Gain is output over input. Yeah, this is your gain. So yeah, here 5.8 divided by 69 millivolt is your gain. So gain is V out over V in. So 5.8 divided by 69 millivolt, you get gain. Make sure you change to the same unit. 69 millivolt, change to volt, then divide with the 5.8, get the answer. Okay, got the idea? Okay. So next, find the resistance of X. Okay, how do you find the resistance of X? Now, of course, you know the gain, right? You know the gain, so you can use 1 plus RF or Rin is your gain, right? So you can find the Rin one. Rin is your X, right? Rin is your X, right? RF we know 120. Okay, gain we know. So you find the Rin. So RF is in kilo ohm. You can leave it as kilo ohm. So Rin also you will get kilo ohm. Okay. So hope you got idea. Okay, now last. State one effect on the amplifier output if reducing the resistance of the resistor X. So what happened? If X you reduced, what happened to the output? So X reduced, gain become greater, right? So you said X is inversely proportional to the gain. When X is reduced, gain increases. So output increases. Output increases. So more louder. Yeah. Good. This is one complete question came out past year. Okay. So how many questions is that? How many marks? 3, 1, 4, 5. Yeah, about 8 marks. 7 to 8 marks. Any questions? No questions, Okay, so let's move on. This we done in your PowerPoint. We done in the PowerPoint. Okay, so we go to the next one. Okay, this one. Okay, next question. Okay, question 3. Yeah. So they're going to ask questions. First, we go for the circuit first. Look at the circuit. What type of circuit is this? Comparator, inverting, non-inverting. Anybody? This is comparator, inverting or non-inverting?
Non-inverting.
So it's non-inverting. There is a feedback. Input is at positive. So straight away go and write the gain formula. So gain is 1 plus RF over Rin to be used. Who's your RF here? Who's your Rin? 120 is your RF. The R is your Rin. And the R is your Rin. Okay, good. So you go back first. By reference to the amplifier, explain what is meant by negative feedback. Okay, what is negative feedback? 2 marks. What is negative feedback? A fraction or all the output. The fraction or all the output voltage is channel back. Is channel back into the inverting input. Okay, a fraction of all the output channel back into the inverting input. That is negative feedback. So remember the definitions. What is meant by feedback? What is meant by negative feedback? What is meant by virtual earth? That's the terms they will ask in exam. Okay, we go down. So now the supply was positive, negative 9 volt. The gain was 25, or they already said the gain of the amplifier is 25. So calculate the resistance of R. Okay, what is the resistance for R? If gain is 25. Okay, so yeah, you know, right? What to do? So how do you get it? So 1 plus RF over Rin is 25. So 1 plus 120 over Rin is 25. So find the Rin. Okay, find the Rin. Good answer. So if you're 120, you put kilo ohm, your Rin also will be in kilo ohm. Okay. So that's the answer for the R. So your gain formula, if anyone predicted this as a inverting, all gone. You're going to use negative RF or Rin, so answer going to be wrong. So it's very important to check what type of amplifier it is. To the question they tell, is it inverting, non-inverting? They never said anything. They just said this is the circuit. That's it. They want you to figure out which gain formula to be used. Okay, next. State the value of output of the amplifier B for input V in. So how do you do this? What is the output if the input is this? So we just multiply by the gain, right? What is the gain? Gain is 25. This is the non-inverting one. So if the input negative means output also going to be negative. Output also going to be negative. Okay. So yes. So output going to be negative. Okay. So input negative 0.08. So of course output is what? Negative 0.08 times the gain, which is 25. So you got negative. The answer is negative because it's a non-inverting amplifier. Never inverts the signal. Signal negative means output also negative. So negative, but check the value. Check the value. Value, if it's 0.08 times 25, check the output. go to the power supply. How much is the power supply? Power supply is positive 9, negative 9. Okay, check this value. If this value is less than negative 9, then not saturated. 0.08 times 25, I think less than negative 9. Smaller magnitude. So never saturate. Okay, so you get this. If you got negative 8.2, so leave it as negative 8.2 the answer. Okay. Okay, so that's the answer. Next, positive 0.4. What is the output? Okay, so input is 0.4 positive. So output also we know definitely is positive. So it's times with the gain, right? Times with 25. So what do you get? 100. 100. 4 times it's 100. So you got 10 volt. I think you get positive 10 volt. Don't rush when you do this question. Check, is it saturated or not? Most of the time, the last question will be saturated one. That's a very common trend Cambridge following. They give a small number first without saturating. Second number normally will saturate. So you go what? Check. It's not positive 9, but positive 10. So how do you write the answer now? So write your answer as what? So you said the answer is positive 9 volt, bracket you say saturated. I say saturated. Saturated will be 1 mark, remember. Okay, you got the idea? Any questions? Okay. Yes, this is one complete question. To about 6 marks. 6 marks. Okay. Let's go another one. Okay. So another one. See this circuit. Tell me, is it comparator inverting or non-inverting? Is it comparator? There is a feedback. Input is where? Input is at negative, right?
Yes.
So, inverting, non-inverting or comparator?
Inverting.
Inverting. This is inverting. Very good. This is inverting. Okay, so this is inverting. Class. Look at the first question. Okay, give me a minute. I get my the power supply. Okay, sorry. Okay. So first answer. Mark with the letter X, the virtual earth. Let's say virtual earth. Of course, the point here, this is the virtual earth, right? The input and negative, this is the virtual earth. Okay. Okay, what is meant by virtual earth? 3 marks. What is virtual earth? You have to say that to prevent saturation. That's first point, right? Anyone? What is virtual earth? So virtual earth is what? First point is to prevent what? To prevent saturation. And to prevent saturation, B negative must be same as B positive. So second point, because what? Because B positive is 0 because earth. Okay. Okay. To prevent saturation, B negative must be. So another 1 point missed out. What is the first point? The most important point is what? The op-amp has huge gain. That's the first one. Op-amp has huge gain. To prevent saturation, V minus must be same as V positive. Because V positive 0, so therefore V negative must be about 0, call virtual. So that's the answer. So op-amp has a huge gain. To prevent saturation, V negative must be same as V positive. Because V positive is 0, therefore V negative must be 0. Call virtual. Okay. Okay, next. In bright sunlight, the light dependent resistor has resistance 200 ohm. Calculate the LDR in bright sunlight, the voltmeter reading. What is the voltmeter reading? And there is a bright sunlight, where LDR resistance will be 200 ohm. We go ahead. So, what is the voltmeter reading will be in the bright day? So LDR is 200 ohm. Okay, this is tricky. Okay, how do you do this? So first identify what type of op-amp is this. This is inverting. Because it's inverting, the gain should be how much? Negative RF over Rin. Okay. So here the gain is what? Find the gain first. Negative RF how much? RF is 4.2 kilo ohm. Rin how much? Rin is these two resistance add up because they are in series. So this is 1 kilo ohm. LDR how much? LDR was found to be 200 ohm. LDR is 200 ohm. This 200 ohm is 1000 kilo ohm. So what do you do? 200 ohm is 0.2 kilo ohm. So it's 1.2 kilo ohm. 1.2 kilo ohm. So the gain is found to be how much? 4.2 divided by 1.2. How much you get?
3.5.
Negative 3.5. The gain is negative 3.5. So the output will be the gain times with the input. The input. So the gain is negative 3.5. Input how much? Input also you have to be careful. You see battery is the other way around. Input is positive 1.5 or negative 1.5. The input. If normally battery up is positive means is positive 1.5 volt. If the battery is the other way around means the input is negative 1.5. Okay. So therefore output will be what? 3.5 times 1.5. It's going to be a positive answer. Okay. 3.5 times 1.5 volt. So do you got the idea? Because the battery is the other way around. The battery negative terminal is up, So the input is negative 1.5. So yeah. Hope you got the idea. This is how you should work out. But your working most important is you need to identify is it inverting or non-inverting first. Any questions? Okay, no questions. Okay. So next, last part. The sunlight incident on the LDR become less bright. State and explain the effect of voltmeter reading of this decrease in brightness. The sunlight incident on LDR becomes less bright. State and explain the effect on the voltmeter reading of this decrease in brightness. So what happened to the output? They're asking. So how do you explain? When it become darker, less bright, what happened to the LDR resistance? LDR resistance will go up on mark lah. When less bright, resistance of LDR goes up. Therefore, Rin resistor goes up. Therefore, gain become smaller. Therefore, output become smaller. Okay, decreases. Output decreases. Okay, so that should be your answer. Okay, question 9. Marks also given here. The mark scheme. So look at the mark scheme, number 9. Low voltage current. Oh, this is a wrong question. Number 9, right? Which one? Oh, no, sorry. Question 4. Yeah, question 4. Yeah, so the last part. Less bright resistance of LDR increases, 1 mark. So M1 mark, you must tell. Gain decreases. So reading, the output reading decreases, 3 marks. Okay. Okay, guys. So any questions? Okay. So this document, let me scroll down. You have about 29 questions. You have 29 questions. This document, you got 29 questions. Okay. So if you go through this question with answer, just go through the question with answer and just go through this STPM2, you will get a better picture of op-amp. Okay. Then you definitely can do one op-amp question in your real exam. Real exam definitely have one with the marks around 8 marks, around average about 8 marks waiting for you every year op-amp. So worth doing. Okay, so maybe after this class, because on Monday we'll be continuing with another topic. We have 2 topics left. We'll be finishing by, we have another 2 weeks to go for your trial also. Try to finish within 1.5 weeks. The last 2 topics. So at the background, you try to do these questions and strengthen the idea. Okay. Any questions? No questions.
Teacher, can be fit into the non-inverting input.
Again, what's your question?
Can the feedback be fit into the non-inverting input?
Yeah, we do have non-inverting, but not even one question came out. Famous is
it will be positive feedback.
It will be a positive feedback, but very low profile. But there is, but very low profile. Ours is always looks like negative feedback. We want to reduce the gain. You know, just now the early you check your PowerPoint derivation, the beta have to be negative. So it have to be a negative feedback. Negative feedback, then only gain drops. So when gain drops, we have all the benefit. Benefit of what? A less distortion, more stability, greater bandwidth. So your case normally will be negative feedback. Okay. Okay, guys. So 2 more questions. So on Monday, I want you to do your practical. Your practical design. Another 2 design. Can you give a try? So the design, you go for the what? Go for your practical book A3. Where's the A3? Yeah, A3. Go to the A3. Okay, the set 3. Go and do D4. If I'm not mistaken. Yeah, I wanted to try with D4 and D5. Draw the diagram. Have a picture of the diagram on Monday. We discuss these 2. Okay, D4 and D5. Just the setup only. Draw the setup. You see, your design experiment. If you get the complete setup drawing, the writing is easy. Okay, the important is the setup. So get the setup for D4 and D5. Okay, D4 is about amplitude of sound dependent to the density of material. Think about it. Okay, and D5 is about stationary wave. Stationary wave. Okay, so this is your homework. So on Monday we'll be discussing these 2. Any questions? No questions. Okay, so I stop here. Thanks.